Good morning, good afternoon. Thanks for sorry for the for the small delay. We had some internet issues. This is the last session in our first virtual IoT series. Today we're going to talk about home automation with Kai Kreutzer from the Eclipse SmartHome project. As always, if you do have questions, please use the Q&A section in the Google Hangouts UI, or use the hashtag virtual IoT on Twitter. Also, make sure to ask the questions while Kai is doing the presentation, so that way we can make sure that we have all the questions at the end and make sure that they get answered. So without further ado, I'll hand it over to you, Kai, for your presentation.
Okay, thank you very much, Benjamin. So, well, welcome everybody. I'm happy to be able to do a presentation today about Eclipse SmartHome. So I'm the project lead, as Benjamin mentioned, of the project. I'm actually also the founder of the open source project openHAB, and in my day job working for Deutsche Telekom, working on a smart home platform. So smart home is all my life, day and night. So to give you a rough idea on what Eclipse SmartHome is about, I'll share my screen with you. Okay, so Eclipse SmartHome is really a project meant to be a framework, a flexible framework to work on good solutions for smart home that please the customers and that avoid more or less topology like this. So at the moment, many products that are out there on the market are more or less a siloed approach. They have their device, they connect to their own cloud service through which they can be remote controlled through their own smartphone app. That's really not the best idea to come to a really smart home once you have many devices in place. So what Eclipse SmartHome is targeting is actually an architecture rather like this that I like calling an intranet of things. So instead of having every single device connecting directly to the cloud and building its own silo, they're all at your home, and it makes much more sense that they communicate locally there. Well, as there is not any common standard one single protocol that rules them all, there's a problem that devices can't talk peer-to-peer because they simply don't understand. They use different radio technologies, different frequencies. Some are cabled, some are radio, others are power line communication, and so on. So there definitely needs to be a central place that allows interconnection and communication between them. That part is usually called a home gateway, and Eclipse SmartHome is just a framework for building such home gateways. Now, to give you an idea about the software stack here and where Eclipse SmartHome fits in, a home gateway will usually run some operating system. Very often that's some Linux system. Then Eclipse SmartHome requires a JVM, as it's fully Java-based. So it requires a Java 7 compliant standard edition JVM. Then on top, as the project is done very modular and you can actually pick and choose things that you need, it also makes use of OSGI. So on top of Java, you need an OSGI container then. And Eclipse SmartHome itself is more or less just a P2 repository of useful OSGI bundles, so to say. So as I said, you can pick and choose things that are useful to you and build then your own solution, your smart home solution on top of that. So actually, the project I mentioned earlier, openHAB, is the one where the initial contribution to Eclipse SmartHome project came from. And this will continue to exist as one solution being based on Eclipse SmartHome framework. Others are there, like, for example, KiwiCon, the commercial solution that Deutsche Telekom is working on, and Also, other solutions are currently built on top of that stack. Now, what kind of OSGI bundles and services are there? Well, in the very core of Eclipse SmartHome, there is a quite basic domain model specific for smart home use. So it covers simple things like, well, switches, measurement values, roller shutters, window contacts, and stuff like that. And based on that domain model, one of the central pieces is an internal event bus. So everything is asynchronous, and events are being sent for your things in the home around. And on these events, other things again like rules or an user interface can then react upon. Now, based on that model and the events, there are mainly four huge categories that Eclipse SmartHome provides services for. One most important block is all around the connectivity. So connecting to different devices, different vendors, protocols, and so on, which all come with their own APIs and way to use them. So this is usually called a binding for Eclipse SmartHome. You bind more or less the abstract model to a concrete hardware and implementation. Furthermore, there's discovery possibilities through your local network and other proprietary things. And then to expose all that is connected on your abstracted model, to expose that to other systems, there's REST API where you can more or less use all the functionality through REST services. Now, the second block is all about automation, because a smart home really only becomes smart by doing something autonomously. And for the automation, for the rule engine, there are more or less the parts that trigger some action. So there are events, it could be time-based triggers, things like that. And, well, the action, so code and logic that is executed. On the modules, we usually talk about more or less complex rules that can fit in a chain, more or less, where you can have multiple computations done, more complex algorithms like for a heating system or your sunshades and stuff like that, and having then the actions controlling things in the end. Now, the third block is about a unified user interface. So, as mentioned in the beginning, usually you have for all your different devices a different smartphone app. That, of course, doesn't make too much sense, but you should really have one single user interface where you can join all information that is interesting together and take control and monitor all your devices. So Eclipse SmartHome really tries to provide mechanisms here to have user interfaces completely independent of any concrete hardware in the background, so that they're really flexible. They don't need to be adapted once you want to add yet another device to your system. Last but not least, persistent services. So persistence is more or less about catching all the volatile events and storing them somewhere, be it in a log file, in a database, or somewhere to a cloud service, for example, as well. Now, just a bit on the history of Eclipse SmartHome project. So the project was proposed autumn last year, created about 1 year ago, and initial contribution from the openHAB code base was done in January this year. We just had a very first release now, and aiming for a second release later this year, so somewhere mid-December, probably. Okay, so Since the initial contribution, there was quite some activity on the project. So the lines of code doubled more or less in the meantime, and yeah, there's continuous developments going on. But before I go show you what's currently on the roadmap and what's being worked on, I want to give you an idea of how the current smart home code can be used as an example on the openHAB project. So I just have a runtime here that I'm starting. This is really the software that runs on a home gateway that can run there. And I'll now demonstrate you more or less the core artifacts and concepts on how openHAB and such a system is built here. So we have the Eclipse SmartHome Designer, which is an Eclipse RCP application which allows you to easily configure your system and set it up through textual configuration. So all of this is based on Xtext and specific DSLs. And as I said, there is a very simple domain model, and we can now, for the demo, say, well, we actually have a color light here. So we have that. We can give it a name, or let's call that our light. Let's be creative. And by that, we more or less defined our very first thing that we want to work with. We can also create something like a switch, which we call present. So we could say, well, here's a piece of information that tells us whether we're at home or not. To make that nice, we can give it a default icon, which is done in these braces. And well, based on that, we can now try to define our very first user interface. Also, all IE supported here. Sitemap, we call that demo sitemap, my home, and we can now say, well, first of all, we need to put a frame here. We now put a color picker for an item which we just defined, which is our light, and we put switch here for an item which is our presence. Okay, so that's more or less a decorative way to define a user interface. We can now try that directly out by calling our local server with a demo sitemap, and we see it renders here. So here we have a color picker. Well, it's not doing anything because it's not connected to any real hardware. Okay, and we have a switch for the present, and the icon there even gets grayed out once we're not at home. So that's more or less the main core things that you can do here. Now to connect some real hardware, there is something called the Things DSL, and in here, as an example, I've just set up for Yahoo Weather, which is more or less a virtual thing. So we say it doesn't have to be something physical in your home, but it could be a web service as well. And for this example, we just say, well, let's use the Yahoo Weather service and provide the configuration for it. And for that, we just have to provide the ID of the location, which is more or less the identifier for the API. Then I've also set up here a Philips Hue system, where I can just say, well, under which IP address that is reachable, and on the bridge, which is the connection towards the Zigbee bulbs of Philips Hue. On that, there is one bulb configured with the ID number 1. So these should be now already available in the system, and in order to connect it, I can actually go to the command line and see that it actually now already received events and updates for that. And let me just list the things that it now knows about. And we get here the, where is it, right up here, the iris bulb. And oops. And we now just have to define for our item that that should be connected to the thing. And this is the thing itself, and the thing has functionalities, and one of the functionalities is to control the color. So now we've connected this item to a physical thing, and I hope that works. I have a webcam working here. This is actually the iris bulb that I have set up here. And if we now go, let's do a refresh here and turn on, you will hopefully see that the light just turned on. So this is now directly connected. We can increase that. We can choose the color. Not sure how quick the update works here. But so this is now directly under our control. So just to give you a very brief idea about what you can do about automation, let us create an automation rule now based on that information. So we can also use the templating mechanism here again. Let's say we call the rule turn off the lights when leaving home. And we can define a triggering event, which is a state change. If my presence changed to off, so we're not at home anymore, then we can say, well, we don't want to do it directly, but we can really directly access Java here and call thread sleep and say 3 seconds later it should please execute something, and we're just taking our light, say send a command, and this command is off. So this is a very simple rule now which we've created, and after leaving home the light should now automatically be turned off. Let's see, we're home right now, all fine. Let's say we're not at home anymore. We count to 3 and the light goes off. Wonderful. So that was more or less just a very, very brief introduction on how the things look like here. Now let me switch back to the slides and remove the webcam picture again. Okay. So as I said, there's a lot of activity currently on the code base of Eclipse SmartHome, and actually the focus of the current developments is to make systems possible that do not require any textual configuration like we've just seen, which is nice for tech-savvy people, but not suitable for the mass market. But really to instead allow to build configuration user interfaces on top, to have auto-discovery mechanisms instead of having manually to configure IP addresses and so on. And for the rules also to make them reusable, so that some programmer can implement certain use cases and other people can very easily reuse these existing rules then. So that's more or less the focus of current things. And the very first part section that we worked on is all about the bindings. So the bindings, in order to support such new ideas, do need to provide a more formal way of themselves, describing the things they allow to connect to, and also providing the mechanisms for discovery and so on. So there are definitely new APIs required, and that's what we worked on that part. Just as an example here, this is a description of just the bulb that we've just seen. So this is now really something formal that can be used in the end by user interfaces to display what a user can add to the system, what was found by the auto discovery, how it can be technically used through supported bridges, and what are configuration parameters and so on. So that's on that. For discovery, we've implemented UPnP support. There is Bonjour as well, and for things like Philips Hue, you also have custom mechanisms, like you connect to the Hue bridge, read through custom APIs what's connected to it, and make that available. So all of that is possible. Now I'd like to go back to my console to just give you more or less an idea of how you would go in order to implement now your own binding. Let me close that runtime and move over to another console window. So this is actually a checkout of the GitHub project of Eclipse SmartHome. And in here you will find a binding folder. Inside this binding folder there is the script create binding skeleton, which you can call, and it will tell you, okay, you need to provide a binding ID. Okay, so my very first binding, you can start, and that's actually now calling in the background Maven archetype, which will more or less create everything for you that is required to get started. While that is running, let me quickly go to the Eclipse IDE. So this is more or less just Eclipse with import of all the projects that you have from the checkout from GitHub. And I've just sorted that by having more or less all the core bundles in here of Eclipse SmartHome in one working set, and then the bindings that exist so far. Now that's still running. Give it a second. It's just checking all P2 repositories here. Okay. So maybe just to mention here in the meantime, so there are just a few bindings for the moment. If you're looking at the openHAB project from where the code came from, you will find here under this link a long list of bindings that exist for openHAB version 1. So there is really support for 80, 90 different things already available, but all of them are really currently in a state that they are only working for textual configuration and the setup. So the goal of Eclipse SmartHome is to really have many of these things migrated to the new APIs to really allow all the new concepts on that. Okay, so we're getting further here. It's now just asking for an author. We say I'm Kai, and now let's just generate it. Okay, generated the stuff. We can switch back to our IDE and go for importing project, which is Eclipse SmartHome binding. And we see now here's a folder, my first binding. Let's open that. We can import in the project, and there we go. After compilation, there are also no errors left, and so you have now really a skeleton to start with. So one of the first things would be to describe your things. We see here the template for such an XML file where you say what are the panels, what can it do, and so on. And one of the main classes to know about, so I won't go into any detail right here now, but one of the main classes is then a handler that is created for you. And that's fairly easy. So there is a method for you to implement handle command. So whenever a command is received for your thing, you are told the channel that you defined yourself to which this is bound, and you can now implement your own, very own logic here to access the remote system. Okay, so you have that in your workspace. Eclipse SmartHome directly comes here with a launch configuration for the runtime. So you can start that up from within your IDE and have that tried out. So it's starting there a lot. And just as an example, I go here to the REST API, which is now started at localhost /REST. And we see the different things that you can now directly access here. So, for example, the thing types that are available in the system. So you see from the view binding, all the different devices that are supported. And there's also the Yahoo weather service available in here and other things. And we should also directly see on the things that are connected to our system, things that we manually set up. And the U is not right in here now. Yeah, right. The U is actually, you can look at that. There is an inbox, so actually all discovered devices are put in an inbox so that the solution or the user can actually decide what to do with them. So we see we have a thing inbox, and it found here the Philips Hue bridge with its serial number and so on. So you can now easily have a user interface saying, well, okay, let's use that thing, and it becomes available in your system. Okay, that much just about getting started to have our own binding here to get these things in there. On the slides, I think we're at the end, right? So let me quickly switch back to the video camera, and we're coming back now to the Q&A session.
Thanks, Kai. So yes, please ask questions using the Q&A or the hashtag #VirtualIoT on Twitter. There is one from James. The REST API looks like a very useful feature. Is there a way to implement access control or security for specific devices which I would like to restrict access to?
Very good question. At the moment, no, that's not yet there, but we've just upgraded the REST API to Jersey 2 and the OSGI JAXA REST connector from Eclipse source. And there's actually good support for security, role-based security already available. And that's the next step that we want to implement. So one thing is there to really have a role-based being available to access certain resources only if you're an administrator of the system or others. But it should also then further go down to a data level so that you are only able to see certain items and stuff like that. But that's definitely a next step then later on.
Because at the moment, there's not really any notion of a user, right? It's really meant to be the intranet of things. So you, as soon as you have access to the smart home gateway, you can control your things, right?
Yeah. Well, actually, authentication and so on is also a matter of the solution that you build on top of Eclipse SmartHome. So for openHAB, for example, we have a basic auth configured on the Jetty. So the REST API as well as the local user interfaces and everything is secured through basic auth. For the commercial KiwiCon solution, we have, for example, an OAuth 2 provider and a security mechanism on top of that. So there's a different solution for user authentication in the first place.
Okay. Maybe one question from me. You said that currently you run on top of Java SE, Java 7. So what would be the typical footprint of smart home, and are you looking at, or does it actually make sense to run smart home on say ME embedded, for example?
Yeah, ME embedded definitely won't work because smart home requires OSGI, and as far as I know, OSGI won't ever work on ME. But SE embedded, so the smaller footprint, full Java version from Oracle, that definitely works nicely and is also more or less the recommended runtime. The footprint itself also very much depends on what kind of functionality you're actually choosing and picking from Eclipse SmartHome. So for openHAB at the moment, as it's all based on the DSLs, and the DSLs are passed at runtime through Xtext, being interpreted, the rules through Xbase and so on, and you might know that Xtext was not primarily meant for embedded use, so the footprint is not too small. So usual heap size of runtime is around 100, 150 megabytes or so. So that's okay to run on Raspberry Pi. It's not perfectly fast, but it's okay, and we have many users using it that way. For other solutions and for the things I just introduced that we're currently developing, there the idea is really to get rid of textual configuration and have other mechanisms in place. And the idea is there that really, if you build a solution that doesn't require any textual configuration, then you wouldn't need the Xtext stack in your runtime. So it can be much smaller. So that's actually the approach that we're doing inside KiwiCon, of course.
Okay. One other question from Pascal on Twitter. Given that openHAB is also open source, why keep smart home and openHAB? Which one to use?
Well, as I tried to explain, Eclipse SmartHome is really meant as a framework and not as a solution for an end user. So Eclipse SmartHome by itself, for getting involved in the core things and developments, that's more or less interesting for companies that want to build their own home gateways and offer more an end customer solution as a home gateway with a certain software stack. So that's the main idea about Eclipse SmartHome. openHAB will continue to exist as one open source solution making use of Eclipse SmartHome. And the cool thing is really that openHAB can benefit from developments that are done in and for Eclipse SmartHome for other solutions, and the other way around. So bindings that will be developed for openHAB version 2, which make use of the new APIs, they will be bindings using Eclipse SmartHome APIs. So these bindings are at the same time then are interesting for commercial solutions and other solutions built on Eclipse SmartHome. So that's really the goal for the future, to have many, many different solutions, and openHAB just being one of them.
Okay, makes sense. A question from Heiko. Actually, I had a pretty much a similar question myself. Is it also possible to add an MQTT event broker in between a client and the smart home backend, so that the server part does not need to listen for RESTful requests?
Yes, well, there is an MQTT connection directly built inside, making use of PAHO. And there are actually two different functionalities for MQTT so far. So one is really more or less to extend the internal event bus to MQTT and having that connecting to a remote broker. Many people actually also use that for a multi-instance setup, so that you can have one broker and sending the events around then through MQTT. But of course, it also works for having that on a cloud-based MQTT broker and building user interfaces that go through that way. That's definitely also possible. And yeah, as I said, Eclipse SmartHome is meant to be really flexible, and you decide how your solution should look like on top of that.
That makes sense. I don't see any other questions. There is a comment from Thomas, though, on the meetup page, who says that he loves the inbox for newly discovered devices idea, and I love it as well. That's actually a great idea. So unless there is a question that's going to show up in the next 5 seconds, I think we're going to end this session here. So I guess you will upload your slides on SlideShare for people who would like to have them for reference, but otherwise, as I hope you guys know, but if you were watching live, you might not need it, but the session was recorded, so just like all the other virtual IoT meetups, you can go to our YouTube channel and watch the session. And with this, I thank you, Kai, I thank you all for your participation, and stay tuned for more virtual IoT sessions in the future. Thanks, Kai.
Okay, thank you.